Now, she didn't tell me what I should use, so I decided to use all the machines and computers in the theatre, including 6BL3500 arc lights, which are moving lights, light-emitting diodes, Maya MSL2 speakers, a DPA boom mic and Sennheiser radio transmitter, and 9 PTV20KS Panasonic overhead projectors. Now, I had 2 hours to answer 20 questions, but I spent 38 minutes doing moaning and groaning, which means I only had 4 minutes to answer this question. Show that a triangle with sides that can be written in the form n squared plus 1, n squared minus 1, and 2n, where n is greater than 1, is right angled. And this is what I wrote. Start the clock. If a triangle is right angled, one of its angles will be 90 degrees. It will therefore follow Pythagoras' theorem. Now, Pythagoras said that a squared plus b squared equals c squared. To put it simply, if you draw squares outside the 3 sides of a right-angled triangle, then out of the area of the 2 smaller squares, this will be equal to the area of the larger square. Now, this is only true if the triangle is right-angled. Oh, come on, Bluey. The A-level question is an algebraic formula for making right-angled triangles. The largest number in this equation is n squared plus 1, which means it is the hypotenuse, which is the longest side of the triangle. To find the area of a square, you must multiply the length by the width. So the area of this square is 2n times 2n, which equals 4n squared. And the area of this square is n squared minus 1 times n squared minus 1, which equals n to the power of 4 minus 2n squared plus 1. Now, if we add these two together, this equals n to the power of 4 plus 2n squared plus 1. Now, we must find the area of the square on the hypotenuse, which is n squared plus 1 times n squared plus 1, which equals n to the power of 4 plus 2n squared plus 1, which is the same term. So the area of the 2 smaller squares adds up to the area of the larger square. So all my squares fit together to satisfy Pythagoras' theorem.